This illustration deals with equipment in accordance with NEC 504.4. This illustration talks about the equipment that's used with an intrinsically safe installation. Now, notice some of the NEC facts that you might want to know about is the reference of an intrinsically safe circuit has been in the NEC really since 1956. It really came about in the mines first as detecting, methane and stuff, explosive type material like that in a mine. Notice also, if you want to know more information about intrinsically safe equipment, and see page 21-16 in the Stallcup's electrical design book. But notice the note talks about the power source can operate at less than 50 volts. It can operate at a voltage that if an arc developed and the output of it, that it wouldn't create an electrical arc that would exceed 80% basically of your ignition temperature of a gas or vapor. But notice the equipment will have a Zener diode, as you see listed in the illustration. It might have a fuse and a resistor, and as say a fault or some short circuit develops, it will avalanche amount of current that would not exceed ignition temperatures of gas or vapor, say, and this, I'm just using this as an illustration, and the fuse will pick that up and open the circuit up, and the resistor naturally deals with the voltage and the current. But sometimes that Zener diode will be damaged. So some of your equipment will come with maybe 2 of these Zener diodes, or even maybe 3, depending upon the designer. But notice you just have a sensing path that will pick up the energy path to ground under a fault condition. Now, simple apparatus that is used with intrinsically safe systems does not allow the parameters of this system to exceed a certain value, and the equipment is listed based upon this concept. In the illustration, you see the first bullet is 1.5 volt. The next bullet you see is 100 milliamp, and the next bullet you see is 25 milliwatts, and this is just a circuit design here, but whatever the gas or vapor ignition temperature is, this system is designed so that an arc due to a short circuit or ground fault will not exceed the ignition temperature of the gas or vapor and involve the dust cloud or the dust layer, whatever it may be. Whatever the designing engineer is designing this circuit to be usable in such a classified area as gas, vapor, dust, flyings, and so forth. But this system is usually used, and where I've seen it the most, is where it's a gas or vapor involved. And the figure 4-21 just simply illustrates the equipment and some of the characteristics and advantages of using this system in accordance with 504.4.